The stack data structure has got many applications, and three most useful applications of the stacks are recursion implementation, function call implementations, and arithmetic expression evaluation. Today we are going to talk about how a stack will be used to evaluate any arithmetic expression. When computer scientists conceived the idea of high-level programming language, they had many hurdles, and the biggest one was how to generate a machine language instruction that would evaluate any types of arithmetic expressions. Take example of one arithmetic expression. Here in this case we have x equals a divided by b exponent c plus d multiplied by e minus a multiplied by c. This expression has got many meaning, even if it is uniquely defined, say by full use of parentheses. Now, so in spite of defining any expressions by parentheses, still there is a lots of problem in generating a correct and reasonable machine language instruction. Fortunately, today we have a very good, elegant and simple solution for this part of problem, and it is so simple that the compiler writing has become a very minor issue now. So when we evaluate any arithmetic expression, we have two things are there. One is the ordering of operations or ordering of operator, and second is called what we call them directions. We'll talk about all these things in detail. Let's try to see these expressions now. So when we have a, in this case, you see this slide now, we have a, b, c, d, e, a, c. They all are called operands, or sometimes they call variables, and all the division, multiplications, all are called operators. So some programming language gives you large set of operators, and all these operators are of different types. Some are called relational operators, some are called arithmetic operator, some are called a different type of operator. Depending upon their uses, all the operators are different types. Now this is one part of it. The second thing, all these operators have given some precedence, some priority. The highest precedence operator are executed first, and the lowest precedence or lowest priority operators are evaluated at the end. Let's see now. So two things we are talking about. One is when you evaluate any arithmetic expression, the most important thing is how they are going to be executed, and that is done by the priority of operators. And the second is the directions of operator, whether they will be executed left to right or they will be executed right to left. Let's see one example to explain what exactly we mean by directions of operator. What we are trying to do, we are trying to evaluate this expression, and the expression is that a exponent b exponent c. Now if you recall the previous expression, there all the operations are executed from left to right. For example, if you have written a plus b plus c, so first a plus b will be evaluated, its result will be added with c. In this case, the direction of operator is of different type. Their directions of operator will be from right to left. In this case, first b exponent c will be evaluated, and then its result will be will be evaluated with a. So now once we have understood priority of operators and what we call them directions of operator, now this real thing is like this now. Then how a compiler is going to generate a machine language instruction which will be correct and reasonable. So the solutions to this problem is that you have to rewrite this expression into different form, and let's call them a postfix notation. Whenever you write a programming language, you write basically in infix notation. Let's define now what exactly we mean by infix notation. The first is called infix notation. In this case, the operators comes between the two operands. When operator comes after the operands, we call them postfix notation, and this is the best solution for the problem which we have raised earlier, that how compiler is going to evaluate the expression which will be reasonable and the correct. So compiler always puts all the expression which you write into infix notation in terms of postfix notation, in which the operator comes after. There is another notation where the operator comes before the operand, and this notation is called prefix notation. So we have deal with three types of notation, one used by a programmer, the second used by a compiler, and even this one is used internally by the system. Let's have one more example to convert from infix to postfix notations now. This time expression is A multiplied by then divided by C now. So when you try to convert from infix to postfix, always you try to understand, first try to find out which operator has got highest priority. In this case, this operator has got highest priority. So now first you try to convert this part of the expression. Now how we convert them? First the postfix notations means the operator comes after the operand. So now in this case operands are A and B, and operator should come after that. So we'll write AB asterisk. Now this has become one operand, and this has become operator, and C has become second argument. Now in postfix notation again operator goes after the operands. Now this has become one operator, one argument, C has become another argument now, and this will be the second operator. So the postfix notation of A multiplied by B divided by C will be AB asterisk C and division operator. Let's see one more complicated example to understand the things very quickly. This is the one complicated expression. We have different type of operators. So when we convert from infix to postfix, always try to find out which part of the expression is going to be evaluated on the top, which is of highest priority. In this case, this double asterisk, which is of exponent type of operator, will be evaluated first, and then this operator division and multiplications will be evaluated at the second level, and finally plus and minus will be evaluated. So now you try to find out, first I have to convert them this part into the postfix. I have written BC asterisk asterisk now, and then A divided by this part will be evaluated at the second stage. So now what we have done now, this operator, the division I have brought at the end. Now ABC asterisk asterisk division operator has become the postfix notation of this part of sub expression. Now what else we are doing? And second level I told you that we are doing this one, this multiplication as well as this multiplication. So second part will be put them into postfix notation as DE asterisk, and the third part A multiplied by C will be put them as AC and multiplication operator. So now what we have done is that we have done second level of postfix notation, in which we put A multiplied by B and this expression into the postfix notation, and finally we are putting them plus and minus. So you have this way we are trying to convert them into infix to postfix. So the important thing which you have to understand is, first you try to find out the highest operator, convert that part of sub expression into postfix notation, then you try to find out what is the next higher level priority, then you convert that part of, and so on. This way you try to convert infix notation to postfix notation. This is very important to understand because the whole algorithm is designed around these steps. Now let us discuss what are the advantages of postfix notation. The first real advantage of a postfix notation is that you don't need to have a lots of parentheses. Now for example, let's have this example now. Now in this example, even if you remove the parentheses, the postfix notations will be the same. You do this exercise, we have done a similar exercise for you. So real advantage is that you don't need to have a lots of parentheses, and even without the parentheses, the postfix notations will be the same. This is one advantage. The second advantage will be the priority of operator is eliminated. All the expressions will be evaluated from left to right. So don't need to consider anymore that which is the highest priority and which is lowest priority. Once you put them into postfix notation, it will be executed from the left to right, and no other consideration has to be done. It means that the writing algorithm writing part becomes much more simpler than this one. So now once we have understood some of these steps, how to convert and what are the advantages of postfix evaluations, now let's try to understand. Now we are moving towards how to write an algorithm. Before that, I told you in the beginning that we don't need to write a program in the first stage. First you must have a proper model and algorithm, then only we have to design a data structure and then you have to write a program now. Now see, you have to understand the role of a stack, how a stack is used to evaluate an arithmetic expression using postfix notation. Just assume that you have a postfix notation. Of course, for that also you have to write a program, which we will see at a later stage. First, try to understand why a stack is being used when you are trying to evaluate a postfix notations now. So now compiler or computer uses only postfix notations for your arithmetic expression evaluation. First time, before expression evaluation, first your expression will be converted into postfix notation and then it will be evaluated. Now just assume, to understand this part, that your expression has been evaluated by some part of your compiler program. Now how, once it is done, how compiler or operating system is going to evaluate this one. Now here you see this diagram we have prepared. Here before you, there is one matrix. In this matrix, example is this one. This is a 3, 4 plus 2 asterisk. This is a postfix notation of some infix expressions now. So now here we are trying to explain you step by step how a stack is being used to evaluate this expression now. So there are 3 columns. One is called, what we call them, symbol process. What element we are, what symbol we are scanning. We have to read the character or symbol one after another one. So now, and depending upon what type of symbol we are talking about, we have to do a different type of operation. This is what going to be pushed into the stack, and third will be what is happening here. So the third is simply explaining you what is happening if we read a particular type of symbols now. Just as done in the beginning, just assume that your stack is empty, a stack does not contain anything. Now you know how to design a stack, how to make a stack empty. Now second will be, this is my first symbol, this is my second symbol, this is my third symbol, fourth symbol and fifth symbol. Here we have 2 types of symbol. One type of symbol is called digital symbol or numeric symbol, or we call operands, and the second type of symbol is what we call them the operator now. So okay, now let's start now. Beginning, stack is empty. Now we first we have to read the character. We read the string, this whole expression we have to read character by character or symbol by symbol. So first we read 3. Now, so once we read now, the whole algorithm is based on what type of symbol we are reading now. So if you are reading a operand, then you have to push them into a stack. So what we have done, the action is push 3. So I have pushed 3. Now I got another symbol 4. So what we have to do, so what we decided now, that if we read a operand type of symbol, we are simply pushing them into the stack. Now second symbol is 4, is the operand type, we push them into the stack, so the action will be called push 4. Now the third symbol is plus, it is a different type of symbol, it is the operator type of symbol. Then what we have to do now, we have to pop, moment we write a plus, then we have to, what are the actions we are taking, pop 4, pop 3, and then compute 7 equals 3 plus 4. So what we are doing is that moment we come across any operator, we have to pop a required number of operands from the stack, do some calculation, and finally put the result back into the stack. So we have, so in the next stage, again see this slide now, again the next stage we are pushing the result that came out after adding 3 plus 4. So the action is now push 7 into the stack now. Now next symbol is, just you recall, we have already read 3 symbols now. Now the next symbol is 2. Now this is argument type, this is the operand type, again we have to push. Now just in this case, that what, this is a stack, all the elements are pushed on the stack. So already we have 7, that is the result of 3 and 4. So already we evaluated 3 plus 4. This is your infix notation. This is your postfix notation of infix notation 3 plus 4. So now we have got 7, and now second is 2. So again 2 will be pushed into the stack. Now the next operator, that is the final symbol, is the multiplication. So what we have to do now, moment we come across any operator, we have to pop a required number of operators from the stack, do the calculation, and then again push the result back into the stack. So moment we come this one, we have to pop, stack will be empty, we have popped 2, this we have popped 2 because it is on the top, then we have to pop 7, so we have written pop 2, pop 7, do some computation. What computation? Computation is depending upon what operator. An operator was this one, the multiplication. So we have computed 7 multiplied by 2, that is 14. So again the result has to be pushed into the 14, or simply you want to print the result. So this way you have to write an algorithm, and that is based on a stack. So now let's summarize now how we have written how to write an algorithm of postfix evaluation using a stack. Now this is the way things are working there. First I have to place operands on a stack till we find an operator. We pushed 3 and 4 till we found plus. Remove from the stack the correct number of operands. Moment we have a operator, right? So moment we get any operator, we have to remove the required number of operands from the stack, and then perform the operation, push the result. And this one will keep on continuing till you come to an end, or till you don't have any symbol to be processed. So this is the basic algorithm for a postfix evaluation. Now let's go very quickly about how to write a C language expression, C language program for evaluating this expression. Now, but the basic part of the basic objective of this whole program slide is video presentation, to try to understand the algorithm. You might be writing into another programming language, let's say C++, so whole notations might be different. Now in C language, let's see how new slides, what we have declared now is for writing the C language program for postfix evaluation, we have some declarations that what will be the size of a stack, what will be the size of an expression, right? And then because you can't have a very infinite size, so size has to be limited. And then we have defined certain enumerated data type. You have to data type, and each enumerated data type refers to a particular type of symbol, left parenthesis, plus, minus, divide, and all sort of things, which is named as a precedence. And then we have declared two variables. One is a stack of size 100, and then expression of size, maximum expression size globally. Once we have these declarations, you have to declare them globally, then you start writing a algorithm, a program for it. I don't have a complete program because the objective is to show you only that part of program which is relevant to our discussion. So I have just implemented only one function that we call eval function, and this eval function is basically is returning some result, but it might be containing, right now it is void, but might be containing something else, depends upon how you are trying to implement them. Now what we are trying to do is, here is this function is evaluating a postfix expression called expr. So your whole expression has to be evaluated into expr, which is declared as a global, already I told you, and each expression comes with an end with this symbol, right, that is called null character at the end of the expression now. And all these variables are stack, and top of the stacks are global variable. Now when I told you that reading this symbol means each symbol, let's call them a token now. So for reading this symbol, so there are two parts of this. There are two parts in this function. One is processing the evaluation processing, and the second will be reading a character from somewhere else, and that part is being named as a get token. So get token is another function in this program which job is to read the token, character, symbol, or whatever be, and then return the symbol accordingly. So now once we have, so there are two types of symbol we have to understand, right? One is called operand type of symbol, and the second is called operator type of symbol. So in C language, all the symbols are stored into the character. So if you want to put them as a numeric, you have to do some arithmetic expression, which I will just briefly I will talk about it. So now here is that some declarations already have done. Here is that this is a symbol, this is operator 1, operator 2, right, and this n is basically used to count, because you can't have the maximum size of expression is just 100. So if n becomes 99, from 0 to 99, then more than that the expression will not be evaluated. So n here works just like a counter. Top is -1, that basically refers to what element it is pointing to on the top of the stack, and then this is a function which reads a token or the symbol from some place now. So just I am simply reading token each after another one, and then so once I have read the symbol, once I have read the token, I have to do some expression till I come to an end. So I have written while token not equal to end of system or end of end of S is basically end of my character now, end of my expressions now. Not end means still you have a characters left into the expression. Now I have to compare now. What we have to do now? We have to do like we have to push only operands, not the operators now. So now what we are doing here is we are trying to compare whether the token is equal to operand or not. If operand, then we have to convert them into proper numeric value, and that is the way, this is the way we are doing it in C language, because they are basically in ASCII form, so we have to put them into numeric form, so we have to subtract by 0 character now. So once we have this one, once we get operand, we have to push them into a stack, and that is being done by add function. Now again, what we have to do now, if we have got otherwise, if we don't have an operand, then it means there is an operator, because we are talking about only 2 types of symbols now, or 2 types of tokens now. So if you have a otherwise, there is an operator, and we have to remove the required number of operands from the stack, do the processing, push the result, and so on. So let's see what we have in the next slide now. So what we are doing now, let's just assume for the time it means that we have got some operator as a symbol or as a token now. So we are popping first operand, we are popping second operand, and then basically again checking now, again checking. So token word is basically right now is only meant for operators now. So if the token is a plus, you do some additions. If token is a minus, you do some subtractions operations by again popping 2 operands and doing subtraction operations, and so on. And then here is basically simply what we are trying to do is that again finally I have to return the result from the stack. So basically in this program we are talking about 2 types of function. One function is how to evaluate a postfix notation, and second is how to read a token from expressions now. So now we have defined another function called precedence get token. The job of this function is to return a token, right? So and then pass it to another function where postfix notation is basically done. So what we are trying to do is getting the next token, symbol is the character representation which is returned, the token is represented by its enumerator value, and so on. So basically we are simply returning the token. Now let's see what we are doing now. Here is that each operator is being treated as a one token. So if in case this one, return this one as a token. If you get this symbol, you are returning this one as a token. So we are talking about the moment we come across any operator, we have to return some token. So basically when we write postfix notations evaluations, then simply we are talking about how to read a token, and then depending upon whether we have a token or we have an operand, we are pushing them into a stack and popping required number of operands from the stack and executing the operations now. So now let's move now what we discussed in the beginning, that compiler always puts the expression into the postfix notation, then only evaluates now. So you have to write an algorithm how to convert a piece infix notation into postfix notation. So this part of the algorithm plays a role only when postfix notation is done from infix now. So now let's try to understand that how to convert an infix notation into postfix notations. For converting from infix to postfix, first you have to fully parenthesize the operators now. Depending upon which operator you want to evaluate them first, you put them into that bracket, right? Suppose that by the compiler or language gives you certain priority of operator, but if you don't want to do that way, then you have to put a particular part of expression or sub expression into a parenthesis. So according to the way you want to evaluate an expression, you put them into parenthesis. So you fully parenthesize them and then move the operator, and then finally you have to delete those parentheses. So let's see what exactly we are talking about with one small example. Now this is the example, a divided by b multiplied by this one exponent c and plus and so on. This is one arithmetic expression. Now I want to convert them into the postfix notations now. Already I have given you. Now since we are talking about how to convert them, how to develop an algorithm, let's try to understand graphically what operation we have to do now. So here what we have done, according to, in fact, the way I want, I have to put them into a parenthesis. Let's say this is one parenthesis, this is another parenthesis, and so on. If I want to convert them into postfix notation, I have to move this operator at this stage and finally remove this parenthesis. So the first step is parenthesized, this is what we did, and second we will be delete the parenthesis. For deletion, while deleting the parenthesis, or before deleting the parenthesis, we have to move this operator to the boundary of that parenthesis. So this is the inner operator, this is being done first. So I have to move here, remove this parenthesis, I have to move here, I have to remove this parenthesis. So this way we are doing all the tasks. This is the way we are moving them. So this will move here, this will move here. So finally we have got A, B, C, double asterisk, plus D, and then we are removing the parenthesis. So basically we are talking about two steps, parenthesizations, and second one will be the deletion of those or movement of those operators. If you notice, when you try to convert from infix to postfix notations, one thing is that the positioning of operands are not changed. You move the operator, but you don't move the operands. So operands positions are at the same place. Now just in this case, if I want to convert them into the postfix notation, my A, B, C, D, A, C, all are at the same position. But what is happening? The real thing is that you are moving the operators, not the operands. So this is an important clue in writing algorithms now. So the real challenge or real issue in designing in infix to postfix notation is that how to handle these operators. So the best solution will be that if we get the operators, if we get operands, we'll push them into the stack. In case we are getting the operator, we have to decide what to do. But let's have one or two examples. So sometimes if you don't find a solution, one way you can try to do that, try to solve one or two small problems of different type of problems. Sometimes solution you can find after solving a problem. So we don't know how to move further. Let's try to solve one small problem, convert them infix to postfix, and then evolve certain algorithms now. So what we are doing then now is since the positioning of operands are not changing, so whenever we get operand, we push them into the stack, and whenever we get operator, we have to decide what to do, whether we have to push that operator into the stack or we have to pop the operator which is pointing on the top of the stack. So now let's have one small example quickly. We have A plus B multiplied by C. This is the simplest example one can think of to evolve an algorithms now. Now here is that what we are talking about. Again, three columns are there. One column is the which symbol you are reading or which token you are reading. This is what we are putting them into the stack and what is going outside the stack. When we are getting an operands and operands positions are not changing, we are not doing anything with the we are not pushing the operands into the stack. So the moment we get A, we are not pushing them in a stack, simply put them at output. The second will be now plus. Now plus we have to decide now. So all the operators first will be pushed into this one. So let's say I got first operator. So I am pushing them into the stack, and the output is still A. Now we have got a second operator, second operand B. Now B is an operand. We don't have to push into the stack. So the one step of algorithm is that if there is an operand, you don't push them into the stack. If there is an operator, you push them and then you decide what to do now. So let's say what I have done, plus I have pushed them, but operands I am not pushing them. So I have got a B now. B will again going to the output now. So we have now A, B as an output, and in the stack you have only one operator. So if you have first time whatever operator you get, you have to push them into a stack, right? Now we have the second operator now. Now the second operator is called what we call the multiplications operator. Now multiplication has got a higher priority, so we have to push them into this one. So the second rule of this algorithm will be that if the incoming operator, that is this one, is higher than the operator which is pointing to the stack, then the higher operator will be pushed into the stack. So now we have two operators. One is this one and the second is this one. Now what we have? Now we have a third operand called C. Now C is again as an operand, we have to push them only into the to the output. Now we don't have to push them into a stack, it will go to the output itself. Now we don't have any symbol now left, we don't have any symbol left. It means that now whatever a stack is containing, simply we have to pop them. So first this will be popped, second this will be popped. So finally the output will be A, B, C, multiplication and plus. So the two steps or two issues related to this algorithm will be that in case there is operand, you push them. In case of operator, you decide. If the operator which of highest, if the highest operator, priority operator which is coming, right, then that operator will be pushed. So we have to compare that if the incoming operator is higher than the operator which is on the top of the stack, then highest priority operator will also be pushed. So two rules we have defined now. Let's see some another example, because that is not sufficient enough to write a foolproof algorithm. It might not work for all type of situation, because when we write an expression, we have a parenthesis also, we have a many operators will be of equal priority and so on, or sometimes the high priority operator is on the top of the stack. In this case, what I showed you, that the incoming operator is of highest priority. But think of a situation when the incoming operator is of lower priority or of equal priority, then what we have to do in that case now. Now let's have another example to get a foolproof algorithms now. In this case, we are trying to multiply B and C with A, and then again further multiplying this expression with D now. Here we have two parentheses, opening and the closing, and then we have a two equal operators, this one. Now how the algorithms will evolve, let's see how a stack is working in this type of situations now. So when we are getting an operand, as usual we are passing to the output, stack is empty. When we are getting the first operator, we are pushing them into the stack, and at output again we have only A. Now the second parenthesis, now parenthesis is coming. Now parenthesis, we know that operators which are part of, or any expression which are part of the parenthesis are evaluated first. So this has got highest priority here. Now it will be evaluated, it will be pushed onto the stack. Now again, so we have two symbols on the stack. One is the asterisk, that is multiplication, and on the top we have a parenthesis operator, and output again we have A. Now B is an operand, it will not be stored into the stack, it will go to the output. So at output we have AB. Now again the plus is coming. If lower operator is coming than the operator which is on the top of the stack, then the rule will be that that operator is also pushed onto the stack. Now so now we have three operators onto the stack, and plus it's on the top. Now we get C. Now C again is operand, again going to the output. So now we have ABC. Now, so the real thing what we are trying to evolve in this algorithm is what we have to do when we get the closing parenthesis. So the moment we get the closing parenthesis, the rule will be that you basically pop all the expressions, all the operators which are part of this parenthesis. So we keep on popping all the operators till we come across a left parenthesis, and finally we delete the left parenthesis. That moment we come across a right parenthesis, whatever we had till the left parenthesis, we have simply taken it out, and also we have to delete the left parenthesis. So finally only one operator is left to the stack, and now the output will be A, B, C plus, because only plus operator was within that parenthesis, that in that bracket. Now the next symbol is the multiplications. If the incoming operator, this is the incoming operator, is equal to the operator which is on the top, that is the asterisk, both are equal, again we don't need to push that operator onto the stack, so this will go directly to the output. So we have A, B, C plus asterisk. Now the next symbol is operand, again it's not being pushed, it is going directly to the output. So we have A, B, C plus this one and D, right? Now just now we don't have any symbol, so it's done, no more symbol is left. Then what we have to do now, all the operators which we had, and we have only one operator here, that was sticks, so we have taken it out, so that will go to the output. So finally what we have got, A, B, C plus multiplications, D multiplication. So this is the way output is produced from infix notation. all the operands will go directly to the output, and then the main logic is how to handle the operators. If two are equal operators, then it will only that operator is not going to be pushed. If we have a right parenthesis, left parenthesis, you have to push them into the stack. Moment we get the right parenthesis, we have to remove all the operators till we get the left parenthesis and delete that parenthesis. So now everything is there with us to write an algorithms now. So just roughly, I have again, it is not a full program, this is a part of program. So we have written one small function called postfix function, okay, so job is to take the infix as an expression and evaluate them into the and translate them into the infix notations. And there are some declarations. This was declared earlier in the previous slide when we are talking about postfix evaluations, right? So now and some of the top is again, which will see, it will point to the top of the stack. Now let's move to the next part. You just see in this case, I will just simply again, this function also, if you see this program also requires a get token function, which will read the token, which is going to read an expression character by character. We will call them token by token here, right? So first we are reading the first token. If token is not at the end, right, we are examining whether token is equal to operand or not, right? If token is equal to operand, we are not pushing them into a stack, simply we are passing to the output, right? Otherwise, again and then again we are getting the next token now. So if token operand, we are outputting to the stack. Now again, if token is the right parenthesis, now in this case we are, if you recall the previous algorithms, now if token is the right parenthesis, we have to unstack token until left parenthesis comes. So this is these three statements of the program simply says that till we get the left parenthesis, this is left parenthesis, we are simply deleting all those operators which are stored on the stacks, right? So and then finally we are discarding the left parenthesis. Now, right, otherwise what we have to try to do now is, it could be like, so we have left parenthesis part is over, the operand part is over. Now we have to simply say that how to handle the remaining operators now. If it is greater than, if the incoming operator, incoming stack operator is greater than, if, right, so the operator is, if the operator which is on the top of the stack is greater than the operator which is coming, then simply what we are trying to talk about is that simply we are deleting it from the stack. This is what we discussed now, that if the operators which is on the top of the stack is of highest priority than the operator which is coming, then simply we have to take that operator. But if the incoming operator is highest than that, we have to push them into the stack. So this way we have met all the situations, and finally we delete everything whatever we have onto the stack. Let me quickly now come to conclusions. Today we discussed one important application of a stack, that is how a stack is used to evaluate any arithmetic expression. In this context, we discussed first how to convert the postfix notations, and then we talked about how to convert from infix to postfix notation. And I told you earlier that these two are very important things. Compiler, these are very important things for the compiler. Using postfix notations only, compiler is able to evaluate a correct and reasonable machine language instruction. This is all we wanted to discuss with you. Thank you very much.